Stopping distance. Here we have a car, and around a corner, invisible from the car, is a child. Both are heading for the corner. At this point, the driver sees the child. At this point, they've reacted and applied the brakes. And here, they stop. The distance from seeing the child to applying the brakes is called the thinking distance. The distance from applying the brakes to stopping, the braking distance. The thinking distance plus the braking distance is the stopping distance. The thinking distance is the distance the vehicle travels during the driver's reaction time. It is not the reaction time. Thinking distance is not the reaction time. Thinking distance is a distance. This question is regularly incorrectly answered. The braking distance is the distance the vehicle travels while braking. The stopping distance is the thinking distance plus the braking distance. Factors affecting the thinking distance include tiredness, drugs, alcohol. Factors affecting the braking distance would be road conditions such as ice and rain, the condition of the tyres and brakes. The numbers of passengers increases the mass of the car and so reduces the ability for the car to decelerate. Speed affects the thinking distance and the braking distance. If a question asks you for a factor affecting braking distance, you could put condition of tyres. If the question asks you for a factor increasing the braking distance, you'd have to put poor condition of tyres. Poor visibility due to fog would affect how close you were before seeing a hazard, but then would not affect your thinking or braking distance after you'd seen the hazard. You'd drive more slowly, you'd use fog lights, which makes your car more visible, doesn't particularly allow you to see further, and you'd leave a bigger gap between you and the car in front. Here we have a graph of distance against time, and thinking distance is directly proportional to speed, giving a straight line to the origin. Braking distance increases more rapidly at higher speeds. Stopping distance is the sum of these, so at 5 meters per second, if we add this value and this value, we get somewhere around here. At 10 meters per second, it would be about here, and so on. This gives the stopping distance.